Hello everyone. So we continue our lesson now. We're now on part 3 of our topic on curve fittings now. So we have here fitting a curve with an equation y hat equals kx to the power of n to a set of points now. So this is a power function now. So this is a power function where x is your independent variable now and k and m are your parameters. Okay. So, in part 1 of our topic, that is about a linear function. No? Part 2, an exponential function. This time, it's a power function. So, the first thing to do is we will let y equals to kx to the power of n. No? And then, let's take the common logarithm of both sides. Okay, so meaning, for common logarithm, the base is equals to 10. No? So as you notice, you cannot see 10 no, as the base for the logarithm. So that is understood no, to be 10. So we have log y equals log kx to the power of n. And then we apply the laws of logarithms. Okay, so recall that if I have log a plus, if I have log ab, that's simply log a plus log b. No? And then we can still simplify this. So recall that if I have log m to the power of n, that is simply n log m. Now, so the next step is to convert log y in terms of an uppercase letter y, then log k in terms of an uppercase letter k. So we have the parameter m in terms of an uppercase letter n, then log x in terms of an uppercase letter x. So, so in this case, we have now the equation y equals k plus mx. Okay, so this becomes y, this becomes k, this becomes uppercase m, this becomes x. No? So where k and m are your new parameters, and x and y are your new variables. Okay. Now to fit the curve with this equation, y hat equals kx to the m. Still, we will apply the method of least squares. No? So to determine the parameters k and m. So sorry, this is m. This is m. Okay. To determine the parameters k and m, upon transforming such equation into the form y hat equals k plus mx. Okay. So in other words, since this is a power function, we have to determine a way on how to convert it to a linear function. As you notice, this is a linear function. Okay, this is a power function. So from power function, we will express it in terms of a linear function. Then we can able now to apply the method of least squares. Okay, same as what we did on my previous discussion about fitting a curve, no, with an equation y hat equals ae to the bx, no, similar to that, no. So we are to transform this in terms of a linear function. No? This is an exponential function, right? And we are to transform it to a linear function. So that was performed in my previous discussion. Alright, so we now move with our topic. So let's answer a problem regarding this topic. So we have, let's fit an equation of this form to the data. So we have four data values, okay? First point, second point, third point, and fourth point. So the first thing to do is we will let y equals to kx to the power of m. Okay? We will let y equals kx to the power of m. The next step, we take the logarithm of both sides, the common logarithm, and applying the laws of logarithms as well. Then we will arrive with this linear equation from from a power function to a linear from a power equation to a linear equation. No? So applying method of least squares. Okay. So here's the derived equation in my previous discussion. Na plus b summation x of I over the range from I equals to 1 to n. No? Equal to summation y sub I over the range from I equals to 1 to n. So this was derived before. And we will apply it. No? So in terms of, so this is n, which is the number of data values. So in here we have 4. Okay? And now is 4, the number of data values. Okay? Then we have the parameter a. So in this case, from my previous discussion, this is similar to this. Y equals a plus bx. So in this case, we have a is equals to k. No? A equals to k. Then m is equals to b. So we have b and n. Then x is equals to x. Okay, that's why we have x sub I, uppercase x sub I, y and y, lowercase y, uppercase y. Okay, so since we have four data values, this will now be the simplified equation. We have 4k plus m summation x sub I over the range from I equals to 1 to 4 equal to summation y sub I over the range from I equals to 1 to 4. And then we simplify further, so we can express x sub I in terms of the lowercase letter. As you notice here, what is x sub I here? X sub I, since we have here x and log x, right? So what is the interpretation here? So we have x equals to log of lowercase x. So in that case, we can indicate a subscript I. Okay, that gives us this equation now. There. Similarly, log of y is equals to y. That's why we have y sub I, log of y sub I there. Okay, so I hope you get it. And then what else? So we proceed. So we can simplify now. So this is 4k plus m, and log x sub I, we start with x sub 1. So we have log x sub 1 plus log x sub 2, ending up with log x sub 4. Okay? Because the limit is until 4. Now, equal to the right hand side of the equation, log y sub 1 until reaching log y sub 4. Then we add them all. So we can now substitute. We simplify this. So we have, so this is x sub 1, y x sub 2, x sub 3, and x sub 4. So we have log 1 plus log 2 plus log 3 plus log 4. Okay, so doing that, we'll obtain 1.3802. Okay, on the other hand, this is y sub 1, y sub 2, y sub 3, y sub 4. Okay, so if we take log 0.10 plus log 0.80 plus log 4 plus log 13, we'll get 0.6191. Okay, and that gives us our first normal equation. So upon applying the method of least squares, so we now proceed with the second normal equation. Let's determine the second normal equation. Okay, so this is the equation derived previously upon applying the method of least squares. And in this case, since this is A, because we have the equation y equals to k plus mx, right? So we have y equals k plus mx. This is the original, right? So considering this equation, y equals a plus bx, this was derived, no? And y now is equals to y, no? That's why we have here y sub I becomes uppercase y sub I. A and k are equal here. So that's why we have a here is the same as k here, no? And then m and b are equal as well, b and m. Okay, then lowercase x becomes uppercase x. So that's why we have here x sub I lowercase, x sub I uppercase, and similar x sub I lowercase, x sub I uppercase. So I hope you get it, no? And so we can able to simplify. So as you notice, naulit lang, no? Naulit lang. Okay, so in that case, for n equals to 4, we have now this, no? So we have k summation. So we replace n by 4, no? And now becomes 4. And also we replace x sub I in terms of log x sub I, no? So dito yung equation natin, right? Yung x, kasi ang x natin ay log x, right? That's why x sub I and equal to log x sub I. From my previous slide, na-discuss ko yun that x is equals to log x. And likewise, y equals to log y. So in here, y is log yi, no? Y sub I equals to log y sub I, okay? And what else? No more. Okay, we can now proceed, no? So this is now the simplified form. So we have k, so expanded form, I mean. We have k, then we add all of the logarithms. Okay, starting with x sub 1, ending up with x sub 4. Then we consider the second summation. Okay, so we have m log x1 squared plus log x2 squared, ending up with log x sub 4 squared. Okay, lastly, the product of log x sub I and log y sub y sub I. So we start with x sub 1, y sub 1. So we have log x sub 1 times log y sub 1, followed by I equals to 2, log x sub 2 times log y sub 2 until reaching log x sub 4 times log y sub 4. Okay? And then doing that, we'll arrive with this equation. No? We'll substitute the values for x sub 1, x sub 2, x sub 3, x sub 4, y sub 1, y sub 2, y sub 3, and y sub 4. No? That is seen on the table. So upon doing that, you'll arrive at this equation. And this is now the second normal equation. So what's the next step? After determining the two normal equations, we have to determine the values for k and m using any method. You can apply Cramer's rule, algebraic approach, no? On how to solve this, substitution method, elimination method, Gauss-Seidel, Gauss-Jacobi, it's up to you. So this will now be the result. K is negative 1.0520, M is 3.4974. And since K equals log K and M equals to M, no? So ang K natin ay equals sa log K. From my previous slide, check nga natin. From my previous slide, K equals log K, ito. So we let K equals to log K. No? And tsaka yung M ay equals sa uppercase M. Yung M ay equals sa uppercase M. Okay? So, yung log K na to, na lowercase, equal siya dito. Okay? So, with that, we can proceed with the next step. So, K equals to log K. So, then we can express lowercase k in terms of an uppercase letter K. No? So, K equals to log K. So, considering 10 as the base, so we have 10 to the power of K equals to 10 to the power of log lowercase k. So 10 to the power of uppercase K equals to 10 log K. Since the base is 10, okay, similar to this, which is 10 as the base. So 10 is the base, and then the base for the logarithm is also 10. Therefore, this is simply k. Okay? Let's say if I have e ln x, this is simply e logarithm of x to the base e. Note that ln x equals to logarithm of x to the base e. Log x equals to logarithm of x to the base 10. Okay? So that's why if they are the same, e and e, so that is simply x. No? Similarly, so if I have 10 log k to the base 10, 10 raised to log k to the base 10, so that is simply k, no? Lowercase k. Okay? So that's why I have now k equals 10 to the power of k. So lowercase k equals 10 to the power of uppercase K. So the answer is, so 10 raised to this number, negative 1.0520, we'll arrive with 0.0887. Okay, and then in here, this is direct. M equals to M, that's why that is equals to 3.4974. Therefore, our answer is this. So we have y hat equals to kx to the power of n. This is what we are looking for. And k here is 0.0887. This parameter, another parameter n, that is 3.4974. And this is the a power function. So we fit a power function to a set of points. No? We fit the power function to a set of points. So that's it. So I hope you get it. And this is the activity that you will do. So simulate the solution of the given problem using Excel such that when the given four data points x and y values are changed, a new correct equation is formed. Alright, so that's it. So thank you and good day.